The generic host in .NET provides a way to host services with lifecycle hooks that can be utilized for things like initialization and teardown. But as we'll see in this video, there's quite a lot to it, and the complexity ramps up where you want to host multiple services which invoke async APIs. But our starting point will be a single hosted service which runs synchronously. Here we are in a service which doesn't have much going on at the moment. It's got a couple of things injected into it, and it's got an exit code, etc. So what we're going to do is implement an interface called IHosted service. Now the IHosted service gives us two methods here, a start async and a stop async. The start async is fired when the application is ready to start the host. So what that means is it hasn't actually completed the startup process yet. It's starting the host. And likewise, the stop async is when it's begun the shutdown of the host. Now we're injecting an iHost application lifetime, as you can see there, and that's going to come in very important, as we'll see when we start using it in the start async method. Now, I wouldn't go ahead if I were you and just write an async method to do all of your stuff in that start async. You could probably get away with it, but just remember, it hasn't completed startup at that point, and that's what we use the application lifetime host for, which is, iHost application lifetime, which I'm demonstrating here. We hook into that application started cancellation tokens register method. Not sure if you've come across that, but you can actually register events on an application token, and that application started is an application token. And I'm also including the stopping event here. Now, and I'll also include just a couple of write line statements in that stop async method. Let's make a few observations while we're in that start async method. You can see that we are in a synchronous context once we're in that callback. And so I'm doing something a bit naughty there, and I'm calling an async method in an synchronous way by calling getAwaiter on it. But we need to do that because we are in an asynchronous context there. Then we're setting the exit code to 0 if everything goes well. And then we're calling stop application. Now what stop application does is it sends a signal to the host that everything's done and the whole application can stop. And when I mean the whole application, I don't just mean the hosted service, I mean the host itself can stop as well. So that's the console application, which is hosting the service. Let's go to the program class, which is where that host is, that console application. And you can see on the services collection, I've added that call to add hosted service. And in the generic, I've typed that to our hosted service. The NuGet package I need is that hosting one. And for the time being, I don't need that HTTP one, so I'll get rid of that. And you can see that we are doing a wait on that run async, so we're blocking on that, and that is when our hosted service runs. So when we call run async in that console application, anything that's been registered with the container as a hosted service runs. And so we'll run that and go through the breakpoints, which shows you the order that they get hit, and that shows you the basic lifetime of the hosted application service inside that iHosted service. Before we move on, we're just going to take a look at this console output to examine it a little bit. We've got this indented statement up here, start async exiting, and that's this line of code here at the end of that start async method. Then we've got some other output statements which are from inside the service, and then that delay done. And that all happens inside this application started cancellation tokens register callback. And so that is where you'd put the logic for the service that you want to run. And that happens after the start async. The start async is just signaling the start of the spinning up of the host, and then the application started is when that has completely finished and the application has well and truly started. Under this generic host model, where hosted services are being run under a host, you can run more than one service, and that's what we're going to look at now. So if you look at this main method, which I've got now in front of us on the screen, the hosted services are at the bottom there. I've got an open orders service and a media service. I've got a couple of business services which the hosted services consume, and I've added an HTTP client because one of the business services consumes that. I wanted to actually do something real in these services and not just fudge it. I wanted one of them that goes to a database and the other one hits the internet to get some data. So this is the first one, the open orders service, and you can see we're getting orders and we're just console writing them out to screen. A little bit of details about them from Northwind database. What you can also notice here is the dependency injection here is including the container itself, the service provider. And what we're doing is known as the service locator pattern, which many would say is an anti-pattern, but here we're kind of forced to do that because we want to create a scope, and this is the only way that we can have scoped services. So we need our container to create the scope, and then with anything which is scoped to that scope, any service, will have the lifetime of that particular scope. And so we then just go and get those TV shows. We're calling stop application there, which is interesting because we go to the other service and we call stop application there. So that's two calls to stop application, which you would think is going to be problematic. So let's see what happens. So what we saw there was the first service went and did its work and it called stop application, but that didn't shut down the application because the other service was doing its work. So it was basically blocking. And then the second call to stop application was just a no-op. And once the second service had done its work, the stop async was called on both services and the application gracefully shut down. So where you're not using async, it's really as simple as that. But as you'd be aware, most of the stuff these days is done in an asynchronous way. So what we need to do is facilitate the ability to call asynchronous APIs in an asynchronous context. And there is quite a bit of ceremony and code that you need to do to get this working. But if you follow the pattern that I'm showing you in this video, you'll be fine. So let's take a look at this register callback on the application started method. Cancellation token, and what you can see here is basically the same code that we had in the synchronous version. These lines of code here inside that callback are doing the work, so that is where your hosted service is actually going to be doing the fundamental work that it does. Now we're awaiting an async method. As you can see there, get TV shows async, and it's got the async qualifier at the top there. But we need to take into account the cancellation tokens. And so we've created a token source, and we're passing in that source's token into the async method, and then the normal stuff where we're writing out the data. The other thing that we're doing here is dealing with the fact that we are in a synchronous context. So recall that register method callback is a synchronous context. So we call task.run, and that enables us to run it in an asynchronous context. And we're saving the result of that to a private variable. We're still calling the stop application event, and in the stopping callback, we're calling cancel on that token source. And importantly, in the stop async, we await that private application task that we assigned the task.run result to. And that's important because it lets the async work finish. So if we look at this, we've got our start async, then we've got the started callback. There's all of our data being printed out. And then following that, the application stopping event calls where the token source's cancel method gets called, and then the stop async method runs. Alas, it's not that simple. We're now going to look at the situation where we add a second service. And so what I've done here is I've re-added the open orders service, which was the other service from the synchronous version of the code that we looked at earlier. And I've made that async. So we're now awaiting an async service that gets injected into there. It's much the same as the media service, and if we run that, you can see it's blowing up, and we have a task cancelled exception. So what's happened here is that when the application has called stop application, rather when the first service reached that line of code and called stop application, there's been a problem insofar as we're now in an async context with another async service. And so the first one of those to call cancel, it doesn't block like the synchronous version. They're async. And then when you hit this line of code where we're awaiting the task will have been, for one, will have been cancelled by the other. And so that's why you get that task cancelled exception. So there's not a whole lot of guidance on this and how to handle this situation. I've come up with a way of orchestrating the cancellation of those tokens, and we're going to take a look at that now, as that prevents that exception from being thrown. So let me introduce into the solution the service orchestrator class. The service orchestrator class is what we're going to use to orchestrate those cancellation tokens. And it's a simple class which is providing thread-safe access via an increment completion count method to a count property. There's also a total count property which is used to represent the total number of services. And I've hard-coded it there, but you could pull that out of a config file, an app settings file, whatever. And so we're going to pull that in and register that with the container as a singleton. Now, normally you'd never give a singleton state, but what we're trying to do here is orchestrate state as between two scoped services. And so this is a little bit of a exception to what you would do with a singleton lifestyle service. So let's see our service orchestrator in action. We'll inject it into the media service, and we're going to check in the application stopping callback whether the count is less than the total count. And if it is, we'll increment with thread safety that count property. And so that cancellation token source cancel will only be called by one particular service, and it'll be the one that's the last, the slowest, if you will. Let's do the same in the open orders service. So I'll just copy and paste that in there to save time. And we'll go to the program class. We've hooked everything up there, and so let's run it. And we can see the open orders, then the media services run. There's been no task cancellation exception, and everything's stopped gracefully. And there's one last thing that I'll show you. Microsoft has included a convenience method for working with the generic host, and so you can actually get rid of that and include this run as console method, run as console async rather, and then you just need to await that up the top there. We can run that, and it's the same. Using the generic host to host services is a new way of doing things, and I've no doubt we'll see Microsoft evolve them even more. In a future video, we'll take a look at background worker services, which are a slightly different thing again. In the meantime, please tap that like button and subscribe to my channel if you haven't already. Thanks.